And welcome to IPWEA's webinar on our model specifications. My name is Robert Fuller. I'm the CEO for IPWEA Australasia. Can I thank you very much for all the registrations that have come in. We have been overwhelmed by the number of registrations we've had and have a maximum capacity for this webinar. It's quite likely we'll be running another series of these webinars due to the popular demand that we've had and the early uptake of them. On your screen, you'll see a few housekeeping matters, and this is so that we can ensure everyone has an opportunity for appropriate questions. Specifically, please try and limit your questions to 2 lines by using the chat facility that you'll see on the right-hand side. We're going to be doing approximately a 25 to 30-minute presentation, after which time we'll be allowing questions and answers coming through from our presenters. So feel free to let your questions come through during the discussion time, but we'll be answering them at the end. If we move on to the next slide, we'd like to acknowledge and thank the federal government for their opportunity of supporting this and facilitating the model specifications. These have come about over the last 3 to 4 months of intensive work with research and peer reviewing internationally from Australia, New Zealand, and major contributors by the TAG and the SLSC Council. It's had a significant amount of feedback and quite a voluminous amount of commentary, all of which has been exceedingly positive, I have to say. This has given us great encouragement, and the 2 specifications that you see in front of you, which were released yesterday, are now the subject of this new industry companion set. Next week, same time next week, we'll be doing the model specification webinar for controls. Today is the lighting specification one. The federal government, through Department of Environment and Energy and the E3 program, has facilitated this and has been a very major driver in where IPWEA and the SLSC program is going. They've both funded and provided significant intellectual contribution and leveraging through other departments to enable much of what we've been able to achieve to happen. This is underpinned by the roadmap, which we released approximately 3 months ago, and I'm very delighted to let you know that we've had over 1,000 downloads of the roadmap, but even more importantly, since we released the 2 model specifications yesterday, there's been over 1,000 downloads of the documents, which is indicative of the strong support and pent-up demand for the industry for these particular documents. The Street Lighting Smart Control Council, SLSC Council, is on your screen at the moment, and it's most important that we acknowledge the participation, both financially and also intellectually, of each of these parties. In particular, I'd like to draw your attention to the Local Government Association, to Energy Networks and the Lighting Council, representing the peak bodies in this area, together with IPWEA. You'll see the major suppliers of the industry, Philips, Lightsource, Cisco and Silver Spring Network, as industry leaders and people who are able to provide change management in the process of moving the industry forward. The next slide takes you to the very significant range of TAG, Technical Advisory Group people, who are bringing expertise to everything that we do. They're also very much peer review before we release things publicly, so I'd like to acknowledge and thank them. And from around the world, these companies represent the pinnacle of intellectual contribution in this area and quite willingly have brought that to Australia to assist us through the SLSC program to deliver the model specifications. It's my pleasure now to hand over to the principal author for the lighting specification and one of SLSC's expert advisor, Graham Moore. Graham was well known to many of you, I'm sure, and he'll be taking you through the key elements of the model specification for lighting, and then we'll enable facilitation and discussion after he's taking you through the core elements of that for this webinar. So thank you very much. Over to Graham.
Thank you very much, Robert, and I'd just like to add my sincere thanks to all the people who've helped with this model specification. There's been more than 20 parties, including many Robert's already mentioned, who've done very, very detailed sets of comments to help us with this. You can see the agenda on your screen at the moment. We're going to fairly quickly just give you a refresher about the purpose and benefits of this, talk about how to convert it into a model spec so that you can actually use it and the structure of it, then focus on 4 key issues in the specification, which we think are some of the more interesting ones, and talk about the next steps with this model spec thereafter, and then hopefully give you a really solid opportunity to ask any questions you want, and feel free to send in those questions as we go through any of these issues. We will try to get to them all. So for those of you that participated in some of the consultation workshops, a bit earlier in April, we are going to just very, very quickly recap the purposes and benefits of model specifications. They help you save money, lower risks, get better technical outcomes, and ultimately drive more competition. Individual customized specs can do a great deal for you in terms of de-risking a procurement process. But of course, it's not a specification that you can use until you customize it. However, it is a great start. Now, the principal objectives with this model specification are to help you select the right luminaire for the specific application that you have, including, in this case, pedestrian areas, vehicular roads, and area lighting tasks. So P category and V category, if you're familiar with Australian lighting specifications. It doesn't cover absolutely everything. It doesn't yet cover things like tunnels and flood lighting, but it does cover the vast majority of public lighting tasks, and it can readily easily be adapted for some other areas. There's a large number of technical requirements outlined in this spec. Many of them are very straightforward, and some of them have options associated with them that we've tried to explain and clearly identify, and we'll go through a couple of the more interesting ones. Just very quickly, with respect to the other model specification that Robert mentioned and Brian King will be presenting on next week, the Model Public Lighting Control Specification, these 2 documents are very much designed to work hand in hand so that you can buy lights and integrated control systems together as one package. I'd like to explain all the colored stuff in the documents themselves, just to make it very clear what's going on there with the text. The ordinary black text is material that you'll probably want to leave in the specification. Things that are in a bright red box are essentially explanations to help you understand what the issue is in that particular section, and you can delete those once you've had a read of them. Items in blue are actions. You need to take an action. You need to insert a number, a project description, something in there that you will have to customize. And items in green are options, where you have 2 or 3 options. We've clearly identified those in the green text. So just pay attention to that structure. It's relatively easy to use, but that's the purpose for all the colors. This model specification is structured in a way that hopefully is very familiar to anybody who's doing procurement. Beyond the introductory material, it's divided really into 3 parts. One is sections that would normally go in an information for tenderers section. This is not specification, but information about how to participate in the process, how to respond to the tender, etc. There's then a series of specification sections, and finally a series of returnable schedules that you're asking tenderers to return to you. So hopefully that fits well in your normal procurement process and can be easily extracted and added to that. Now we're very quickly going to talk about 4 of the issues that we think are probably the more interesting ones that people will have questions about. As I said, please fire in any questions if you have any. The first one is with respect to color temperature. This has been particularly hotly debated since about last June, when the American Medical Association came out with some guidance suggesting that all public lighting should be 3,000 Kelvin or less. And just for non-lighting people, 3,000 Kelvin essentially means warm white. We started LEDs at 5 and even 6,000 K, which is quite a clinical white. And we're gradually coming down in what's available in terms of color temperature. The Australian Technical Specification 1158.6, which is not a standard but rather a specification that came out a couple of years ago, that says 4,000 at the moment, but there's a hot debate about whether we stay with that or whether others are more suitable. And some municipalities around the country have started using other color temperatures. I think it's fair to say, though, at the moment there is no scientific or industry consensus on this. It really comes down to a debate about public safety versus public health and ecological impacts. On one side of the debate we have the American Medical Association, but on the other we have U.S. Department of Energy and the Illuminating Engineering Society of North America. And they have very strongly noted in repeated releases that this is not a new issue. It applied to many types of lighting before LEDs. And they have highlighted the risk of reliance on color temperature to assess blue light content. You can actually have 4,000 Kelvin lights that have less blue content than 3,000 Kelvin. It's not really the right measure. You should be using spectral power distribution. And they have challenged several aspects, including that one of the AMA findings. In fact, there's new releases from both these organizations in the last few weeks, and they'll shortly go up on the IPWEA website. Overall, I think it's fair to say that at the moment we've got prominent safety experts, road safety experts, advocating for 4,000 on main roads. The debate is probably more centered now on residential roads and parks, where some parties are starting to use 3,000 or even less. Los Angeles, for example, one of the pioneers with LEDs, is now using 2,700 everywhere. So in addition to a little bit of discussion in the actual specification, there is a link to a hot topics section of the SLSC website. That's going to be continually updated as this issue develops. The second item that we thought worth discussing is with respect to maintenance factors. The model specification gives you 3 options. Number 3 is to stick with the guidance that's currently in ASNZS 1158, both the residential road V category section and the main road V category section. That's documents released in 2005. There's an update underway at the moment. My understanding is some revisions are expected to come out for consultation in the next few weeks. Beyond that, we know this area is widely misunderstood and a number of parties have challenges with it, and we've tried to make that a little bit simpler by giving you some predefined options. One is for urban areas and the other is for rural areas. And the real difference here is to do with pollution. The luminaires themselves, their light output decays over time, but they also get coated with all the grime in urban areas, and you have to account for that in making calculations about how fast the light output will deteriorate. This is what a maintenance factor is really about. You're multiplying those 2 factors together, and it's slightly different for urban and rural areas. Now, we've taken our guidance based on a British approach that's already in use and reasonably widely accepted. We'll revisit this when we see what happens with the Australian standard, but we don't think it's too radically different from where things are heading internationally. The third item we wanted to raise today is with respect to surge protection, and I have to thank here many parties, including luminaire suppliers and some specialist surge protection suppliers who've helped us with this issue over the last few weeks. The sum total of it is that the current guidance in our in the Standards Australia, Standards New Zealand technical specification, which is effectively one level below a standard, and written 2 and a bit years ago, is to use 320 joules, a metal oxide varistor that has that rating. Now, what surge protection specialists have told us is that, first of all, is not really sufficient to define what is needed, and second of all, it's unlikely to be adequate surge protection, particularly in Northern Australia. And there, what we're really talking about is the risk of many, many high lightning prone days per year. We're talking about areas in northern WA, the Northern Territory, and the northern part of Queensland that have some of them incredibly high lightning areas on par with the highest lightning incidence locations around the world. We've suggested 2 options that are slightly, the first of them, slightly above effectively what's being done in Australia to date. It's specified slightly differently than 320 joules. It's 10 kV, 5 Ka, and it's suitable for most areas of Australia, we believe, and it's based on some standards guidance from North America, an ANSI standard. Also coming out of that ANSI work in the United States, where they had to consider areas like Florida, which have just as high lightning incidence as the top end, is what we would think generally referred to as an extreme rating. This is the 20 kV, 10 Ka rating for surge protection. And it's required to be able to handle this a large number of times, at least 15 times at that rating, to be able to pass the tests that apply in this case. And we think that people in the top end should be specifying something like this, a fair chunk above the current standard. The final item that we thought worth raising with you today is with respect to power supplies and control interfaces. And you may not think that this is particularly interesting. Sounds like it's buried in the details, but it really is something you probably want to focus on a little bit. The power supplies are becoming ever more sophisticated digital devices. There's now a number of choices that you have with respect to the type of power supply, and they allow you to do things not just such as dimming, but also to trim lighting, to optimize start and stop times, to reduce initial levels of overlighting. In other words, if it's slightly over-designed, if things are shorter spacing. This also, anytime you take the pressure off an electronic device, it allows you to extend the asset life. And beyond that, some of these systems are now starting to offer tremendous asset management benefits. And anybody who was at the IPWA conference in Brisbane earlier this year will have seen Georgia Power speak very eloquently about what they're doing with respect to the use of Dolly and preloading luminaires with all of the asset management information. When they plug in a smart controller now in Georgia, they are automatically populating their asset register. Really, really interesting development. Now that requires the use of Dolly, which I mentioned. That's our recommended approach. The current version of Dolly is called 2.0, and we're suggesting people specify Dolly 2.0 power supplies and talk to manufacturers about how they can pre-populate those power supplies with asset information if they intend to deploy smart controls either now or in the future. The current most common approach is 0 to 10 volts. The Dolly 1 is perhaps fading from the scene. It's now being superseded by Dolly 2, but some parties are still offering it. And something you're likely to hear a bit more about over the next year or so is something called Zaga. And Book 18 of Zaga is specifically for outdoor lighting, and it offers both a new approach to power supplies. It's perhaps a little bit more suited to the digital world, and a new interface. You might have heard people talking about the 7-contact NEMA base for photocells. This is moving to another interface These are all effectively different types of USB, but the Zaga approach we'll see how it turns out, but it may be more appropriate as we move into an ever more digital world in the outdoor space. So before we get to questions, one last slide. We have these documents now loaded up onto the SLSC website. They are free for all comers based on funding that has come from the Commonwealth Government and the Council and TAG members in the IPWA program. I'm delighted to say that some major cities have indicated a very strong desire to start adopting these documents in the next few weeks and months, which is great. IPWA is going to evaluate demand for training in more detail than we can do in a short webinar like this over the next few months, and keen to hear your feedback on that. And important to realize that these are model specifications that are living documents. This is a very fast-moving area, even faster with respect to controls and LEDs, and we will need to update these documents, and that in large measure now rests on you, the users of the documents. It's essential that you participate in helping to improve them. The momentum for them will only come through adoption by users, and they will only improve with your guidance. If there are areas that are deficient, inadequate, or need improvement, we need to hear that back from you. So if any of the items presented today raise any questions for you, we'd be delighted to try and handle those now. It's really over to you. So the first question that I have here is from Scott Holland at Brisbane City Council. He's asked whether the IPWA can reference safety expert documents advocating 4000K. I think there's probably only two I can really point to at the moment. One is Professor Ron Gibbons, who was out here in Brisbane earlier this year at the IPWA conference and runs Virginia Tech's very impressive road safety labs. He has written about this, and I think would be very happy to take direct questions as well. He has a real affinity for Australia and would be very happy to take inquiries about it. And the other is Rensselaer Polytechnic Institute in the state of New York, which has also written to some extent about this. But I'd also advocate reading the U.S. Department of Energy and IESNA documents. We will, over the next few days, be updating what's on the IPWA website, helping you easily find the latest updates. Are there any more questions? I'd be very happy to take them if there are. We have a question from Andrew Downey, who I believe is at Geelong, the city of Greater Geelong. He was asking if we were doing a specification tomorrow, what would you be putting in? I'll answer that from my perspective only. I think I would stick to 4000K because the people I trust most in terms of road safety, to come back to the previous question, are saying that the safety outcomes are optimized at around 4,000. In fact, I think they're actually suggesting 4,100. I think the biological reason for that is essentially at very low lighting levels, our eyes are attuned to moonlight, and that is the color of bright moonlight. And the residential roadways, I think it's certainly something where you could consider going a bit lower. People are simply more comfortable at warmer color temperatures as you get to lower lighting levels. I would absolutely consider 3,000 for parks and reserves. I think in general, many people feel much more comfortable. And remember, with LEDs, as you get to warmer color temperatures, you're not necessarily sacrificing color rendition. We have a question that's related to that from Andrew Brown about existing luminaires and how do they compare in terms of color temperature. The initial luminaires in this market were, as I mentioned, at 6,000, which is a very cold and clinical white. We then went to 5,000 with some of the ones that were first deployed at large volume, and we're now generally at 4,000. But I think if you talk to any of the major manufacturers, including the Council and TAG partners that are luminaire manufacturers, you'll find that almost all of them now are willing and able to offer other color temperatures, 3,000, 3,500, some of them are offering 2,700. We then have a question from Amber Rod asking if she thought Essential Energy would support smart controls in new deployments. I'm sorry, I can't speak for Essential Energy, but I can tell you about some of the findings from the IPWEA roadmap research that was done last year. And overall, looking at both cities and the utilities, we have very, very low levels of smart controls deployment to date. That said, many utilities are investigating it currently. I know I do a lot of work here in Sydney with Ausgrid, and they're about to deploy 5 different smart controls trials. So I can't speak for where Essential Energy's got to on this, but it's certainly moving very quickly, and I think there's some real asset management benefits for the utilities. And sorry, Andrew Brown had a clarifying question saying he was actually referring to sodium versus mercury vapor lamps. Sodium is in the very low 2000s Kelvin, but important to also recognize it also has very, very low color rendition, something like 20 on a scale of 0 to 100, the color rendition index, with 100 being normal full daylight. Mercury vapor is quite a blue light, up around 4,000, but again, not a particularly good color rendition index, so it doesn't give the full spectral distribution that things like metal halide or LED do. Scott Holland from Brisbane has asked a question about whether the industry is looking at variable color temperatures, as is happening with interior LEDs. The answer is yes, probably a couple steps behind. One of the first trials I'm aware of is in the United States, in the state of Minnesota, where they're actually changing the color temperature of the lighting through the course of the night or in response to different climatic conditions. So the answer is yes, although I'm not entirely sure that you could go ahead and buy one today in Australia, but it is absolutely coming. There's absolutely no question about that. Be happy to take a couple more questions. We still have a few minutes if you have any others. Thank you very much to those who put questions thus far. Just coming back to the issue of color temperature, because I know that's an area that a lot of people are interested in. I might mention a couple of early different perspectives on this that have already happened in Australia. Very much worthwhile looking at the Sunshine Coast's absolutely excellent street lighting master plan or public lighting master plan. They are moving to warmer color temperatures in that. And I think also worth looking at the City of Sydney and their public document, their lighting strategy. The City of Sydney advocates for 4,000 Kelvin, as I recall, on main roads, and between 3,000 and 4,000 on other types of roads and in parks and reserves. I have a question from Steve Clayton about dark sky compliance and whether 4,000 actually provides compliance with dark sky requirements. I think the International Dark Skies Association has been a very strong proponent of 3,000 or less. But I think it's also important to realize that on average the difference between 3 and 4,000 is perhaps only 25% of the blue light content of the output. 3,000 does still have blue light in it, just much less than 4,000 and a great deal less than 5,000 and 6,000. One other issue that somebody's pointed out to me here is with respect to the use of color temperature and wildlife. And in fact, here we really should be talking about the issue of spectral power distribution. Different lights put out different amount of energy in different parts of the spectrum, and turtles and seabirds and other environmentally threatened species can react very negatively to certain parts of the spectrum. And so if you look up things like turtles and LED lights, you'll see that there's some very interesting trials going on in places like WA and Florida, trying to selectively tune lights, pick out parts of the spectrum to use and not use to help with behavior of endangered species, to not attract them up onto roads, to not disrupt nesting behavior, migratory behavior, feeding behavior. If you're in a very ecologically sensitive area, this is something that really requires expert assistance, but it's something that is now possible with LEDs. You can take out parts of the spectrum or have other parts that you wish, and therefore greatly mitigate some of these issues. Another question from Brisbane City Council with respect to something called bug ratings. This is a system in the United States developed by the IESNA, the Illuminating Engineering Society of North America, and it's about limiting glare in different directions from luminaires. We don't have a system like that in Australia at the moment. It tells you in great detail about what the limits are in different directions from the luminaire, and it's certainly something that could be adopted here. We have limits on glare in our standard, and I'm sure they're going to be improved in the next iteration of the standard, looking at what's called threshold increments, but it doesn't quite do it in the same way as these bug ratings. So I'm not on the standards committee. Probably for more information there, you'll need to talk to somebody who's on the standards committee. Andrew Brown has asked, what are the U.S. medical recommendations on color temperature based on? It really comes down in terms of human health to a concern about circadian rhythm disruption. The blue light that everybody keeps mentioning is really because, the concern is really because that is the maximum point in the curve of spectral output that can disrupt our sleep. If you have teenage children and they're looking at their smartphones late at night, you'll know that they don't go to sleep, and that's because it's effectively acting as a stimulant, and it severely disrupts your circadian rhythm. And the concern is that if we start to use LEDs with high blue light content, we may have all sorts of negative effects on human health. So that's really where the U.S. American Medical Association is coming from. That is their concern. Now, you also need to consider issues of dosage and duration, and I think the smartphone that's 6 inches in front of your face is a considerably higher dosage, and you're looking at it for longer than a very low output street light that might be 20 meters away from you. So it's not quite as simple as just looking at the color content or the spectral distribution. Okay, well, thank you very much. If you haven't already done so, you should be downloading a copy of this document from the SLSC website. I know that a great many people have over the last 24 hours. Please do follow up with any further questions or feedback as you start to get into it. I'm sure it's not perfect and can be greatly improved, but only with your help. So finally, just a final thank you to the Department of the Environment and Energy, who helped with some of the funding for this, as did the Council and the SLSC Council and Technical Advisory Group, and a particular thank you to all of those members of the Council and TAG who helped with very detailed comments on different early drafts. Thank you very much for joining us for this webinar today, And there's another one next Thursday. And as Robert said earlier, if you haven't signed up to that, there's consideration being given to staging additional webinars because the response has been so large. Thank you very much. Goodbye.